Hey everyone, welcome back. This is Vivek Bharata. In my previous video, which is on Kafka fundamentals, I received few comments asking to basically create the practical version of it. So in this video, we'll be covering the practical side of the whole Kafka fundamentals. We'll start with one simple service and also we'll set up the Kafka infra in the whole Docker desktop setup. And we'll start spinning one after the other service and we'll see how the data is being flowed from producer to consumer via the Kafka across different topics and partitions. Let's get started. To begin with, I'll walk you through the Docker Compose file where we have the Zookeeper, Kafka, and Kafka UI. First service is Zookeeper, where it manages all the metadata for the Kafka and basically responsible for the different brokers, leader management for different partitions for a topic, and all that stuff. So this is Zookeeper. We just pulled it from Bitnami Zookeeper with the specific version, and we need to set some environment for the local dev setup. And currently the port is listening at 2181, which is again forwarded to the host machine. Next up, we have Kafka, self-explanatory. The image we pulled it from Bitnami Kafka. Currently, we have the by default 9092 is the port, but due to the latest version, there are some slight changes, and we need to explicitly mention these non-variables and external we need to access with 9095 because the internal is will be 9092. It's all configuration part, not the actual focus area for this video. So assume that 9095 is the port where we access Kafka. Simple, okay? Then self-explanatory, this specific Kafka service purely depends on Zookeeper. So only Zookeeper is up and running properly, then only Kafka will be ready. Next up, we have Kafka UI. Again, this is for the Kafka management. Simple UI, open source. Currently, it's listening at 8080, and it is again forward to the host machine with the same port. We have some environment variables just to suffice to have this local Docker desktop setup. That's it. Okay, and depends on self-explanatory, Kafka, and Zookeeper. These two services. That's it. Okay. Now let's look at the Docker desktop. Over here, if you can see, we have this Kafka practice. This is the current folder, and we have all the services. Let's remove this thing for now in the containers hole. Let's start the service from over here. So that would be Kafka practice. So inside this folder, we can just do docker compose up -d is to detach mode. Let's set it up. Okay, I already pulled the images, so that's why it's so fast. But if it's for the very first time, it might take a while for you guys. But if you see Zookeeper, Kafka UI, all are started. Now let's open Kafka UI in browser just to walk you through the rough dashboard, how it will be. So over here, if you see, we have one cluster which is online, that is our local cluster. And over here, we can see only one broker setup for now as part of this specific video to get started. We can cover more in the later advanced videos if you really guys need to have the multiple brokers and how the different partitions will choose one broker as a leader and the other stuff also as well, and so on. Okay, now moving on to topics. Right now it's all empty because we just created now, so everything is clean to kickstart. Okay, I hope this is clear. Now let's move on to the first script, that is init.js. In simple terms, the whole responsibility or the whole purpose of this init.js is basically to bootstrap the Kafka in a way that we need so and so topics with the defined partitions and all that stuff. Okay, so we are using Kafka.js as a Node.js module, and we just imported the Kafka over here. And client ID, this is basically to tell that okay, this is the different instance and this is a service with this client ID. That's it. Okay, and currently we have only one broker setup, so and that is localhost 1994. That's it. This is the port which will be same as the Kafka's port 9094. Okay, now we have topics to create. Let me just minify all this. Now this topics to create is a definition where what are the number of topics we need and what is the partitions, replication factor, and there are so many other meta information you can give. So in this video we are covering two topics. Order created. Whenever order is created, we'll just fire an event from one service, that is order service. I'll just cover that soon. So number of partitions, we defined it as 3. Okay, we have another topic that is user.updated and partition is 1, replication factor 1. Simple. So two topics, order created, partitions 3, user updated as another topic, partitions 1. Simple. Okay, I just define it as an array of objects. Now we can just create a Kafka instance with this client ID and brokers. We'll get this Kafka object and the self-invoking function. And over here, I'm just getting the admin instance from this Kafka object what we created. That's it. Okay. Now the fun part is, first this admin instance will try to connect to our Kafka. This is the line where it connects to the Kafka broker. And once it is done, we'll first get the list of topics currently in Kafka. It will be empty or it can be other meta internal Kafka topics. You could ignore this just to see, okay, what are the current topics before even we create the new topics. Okay. Then with the simple function admin.create topics, we can pass topics as a key, and the value is simply array. The This thingy might be a bit complex but self-explanatory. What we are doing is topics to create is an array of objects what we have. I'm just mapping it and returning in a defined format. That's it. So we need topic name, the number of partitions, and replication factor. That's it. Okay. And later I'm just logging this result set over here, and if there is an error, if there is any error, console logging. And after finally everything is done, always open connection should be closed. So on finally I'm just disconnecting from the Kafka. Simple. Okay, let's run this one and see how this thing goes. Node init.js. That's it. So existing topics empty, created true, Kafka admin client disconnected. Okay. Now let's jump back to Kafka UI, and over here if we just refresh, and if you can see, we created two topics, right? Order created with partitions 3, user dot updated with partitions 1. Simple. Replication factor is 1. Currently currently if you can see, number of messages is also 0 because we haven't produced any messages to these topics. Simple. Okay. Consumers also will be empty because we haven't even started any consumer instances. Okay. Now there can be a doubt like, okay, what if we run again? We'll get error. Simple. So if you see here, existing topics, okay, user updated, order created, the one what we created earlier, and later we got an error stating that some create topics so and so, topic creation errors and all that stuff. Created is false overall. Okay. There won't be any harm on over here, but the same script if you just run, it will fail. That's it. I hope till this part it's all clear. Now let's move on to the fun part, that is order service, where we actually interact with Kafka. Okay. So first service is order service. Overall we have three services: order service, user service, and mailer service. In this example, order service acts as a producer. So let's just jump into the order service. It's a simple file. This is again not to judge on the way how I have written this. This is just to showcase that how the, in a simple way, so that we can just create an API, and from that API we'll just send an event to Kafka topic, specific topic, that is order created. That's it. Okay. So let me see if I can just minimize all the definitions so it's easy to walk you through, and we can close this terminal as well. All right. So express, body parser, self-explanatory, nano ID. This nano ID is basically simple npm module where it will give you a unique random generator with a defined length of characters. Simple. Okay. And we have this Kafka. Okay. We just created an express instance, body parser used as a middleware. Now we just created the Kafka instance with client ID as an identification, as this is order service. So we just define it as order service. Currently we have only one broker that is listening at 1994. Kafka broker, so localhost 1994. Simple. Okay. Now later with this Kafka object, I'm just creating a producer instance. That's it. Okay. I'll just come to the order service. This order service again, as per the, let's say if you're building in a Nest.js application or any of the well-defined frameworks, the services will be different files and all, but this is just for the sake of closing the whole loop. I just created in a single file. I hope this makes sense. We'll just cover this order service later. Moving on, the routes. Only one route for now. API v1 orders. Okay. What exactly it does? Inside, I'm just calling order services create order. Okay. And then assuming that there is some meta stats that we need to update for a user also, then we'll do that business logic and we'll push or produce another event to different topic, that is user updated. So, and again this is making it as a configurable so that we can tweak this flag and we can see how the messages are being transferred on and off with user updated topic. Simple. Okay. So if we send it as true, then we'll just call order service update user. I'll just cover these definitions, but simple. So this API v1 orders will just create this order. Inside we are basically doing, assuming that we'll do some business logic and save it in the DB, then later we'll just push it to Kafka topic. That's it. Okay. Accordingly I'm just returning 201. Simple. app.listen port so and so. This for graceful shutdown during our development. Whenever we want to restart the service or something, we'll just do control C, right? So this SIGINT or the process level, this is like a handler for that. And once we get that interruption, we'll try to disconnect from the Kafka. Okay, and we are exiting over here. That's it. Okay, now let's cover the order service. So what exactly the definition of order service? So inside order service, we have this connect Kafka. On this order service instance creation, we'll just try to connect to the Kafka with this producer object. That's it, producer.connect, simple. All this, again, there are so many meta information you can configure, but in a simple terms, this is how we can connect with the producer instance. All right. Now, create order is the function what we are calling over here, right? API v1 orders. So create order, assuming that after all business logic for order creation, including DPO operations, is done. That's an ideal way. Once everything is done, we'll try to push a message to a topic. So here the key, remember, if you can remember, this key will define, it will basically do a hash inside the Kafka and by divided by the number of partitions, and it will resolve which this specific message should save in which partition. Simple. Okay, so over here key, we are using user email as a key. Okay, so I'm just adding a log producer.send. This is the signature topic, so to which topic this producer should send the message. So order.created. Okay, and messages we can pass multiple, so that's the notation of array over here. So key is key over here, that would be user email. Then the value, so value here stringifying order id, again creating a random order data, whatever we pass it from the API, that will be stored again timestamp. That's it. So this simple function will push a message or a number of messages based on this definition to this topic. That's it. Okay. And after that, I'm just returning a simple object. That object is order and passing down and returning it as a response as well. Okay. Now update user, same funda. Over here on the try catch, if you see, key is again user email. I'm just using user email and order ID, and it's a simple message. This is just to showcase you that okay, one single producer can actually send to different topics as well. Okay, this topic here over here is user.updated, and this is a message. Key is user email again, order ID, user email, and timestamp is the payload value for that specific message. Simple. And I'm just returning a simple object over here. I hope till this part it is clear. Kind of a theory sort of thing, but again, this is actually a code, right? Okay, now let's run this service and hit this API via Postman, and we'll see how the messages are being sent. Okay, so let's open terminal. Let's clear this out. npm run order service. I just have this as a definition in package file as a start scripts, order service, mailer service, user service, AC. This is autocannon. I'll just cover that at the end of the video. Okay. Now if you see, order service has started and currently it is listening at 3000. Ignore this warning for now. Go to the Postman, and also before triggering this request, let's look at the Kafka UI. So all set, order created, partitions 3, number of messages 0 overall. Okay, now switching to Postman, and this is the user email I'm doing. Let me just do it as user1 for now. Okay, user1@vivekbharta.com. Simple. Okay, send user update true. Let's just start with a simple flow so that the message will only send to order created. That's it. Okay, let's send. Okay, I think we got a response as well. Let's send again. So overall we should see 2 messages. So jumping back, refresh, number of messages 2. Okay, I'm not sure if this is visible. I can just zoom in maybe a bit. Okay, I hope this is clear, a bit more visible. Okay, now if you see number of messages 2 for this user order created. Now I'll just open inside. Total number of messages, I can see 2 messages what we sent, and partition is 0 again. So the reason the 2 messages went to partition 0 because we send the same key, that is user email. It might send, if you just increase 2, it might or it might not send to the same partition due to the hashing logic and all that stuff. So let's see how this thing goes. Now the second message, if you see next messages, so the latest message came to partition 1. So if I send another 2 times, let's say with the same user 2, send, okay, 2. So total 3 messages should be in partition 1. If you can see, let me refresh, 3 messages. Okay, now if I jump back to user 1 again, it will definitely send to partition 0 only, because this hashing logic will be persistent overall. So as long as the number of partitions change, the same key will always make sure that Kafka will send the message to the same partition for sure. Okay, so if I just send another request for user 1, topics, refresh, order created, inside if you see partition 0, total message 3. Earlier it was only 1, right? Now let's see if we can increase and if any message will end up in partition 2 as well. So we tried user 1 and 2. Let me see if I just add user 3. Okay, luckily it came at 1 only. Maybe it's in a cyclic thingy. Maybe let's say if you just do 45, send. Okay, the second message also seems like it came to the partition 2. Let's see over here, user 42. Partition column is in the second column. If you see partition 2. Okay, maybe let's see 55 then. Send. Refresh. 55 is also at partition 2. Okay, so it varies, but you got the point, right? As long as the number of partitions doesn't change, for the same key the message will end up in the same partition for sure, and the order will be definitely same. So that's the main important factor in Kafka, where an order will be accurate always for in a partition level for sure. Right now if you see, we are pushing messages and we have all messages over here, topics, first offset. So I'll just cover these offsets one, but overall if you see, I'll just refresh again. So overall if you see, I think messages count are all same. Let me just see if I can just go back to user 1 and send one more time. So in partition 0 we have 4 messages total. Okay, now let's jump back to one simple diagram. So till this part we have only one order service, one producer you can say, and we are just sending the messages to order created right now. Okay, so we have some messages in p0 is partition 0, partition 1 and partition 2. Okay, and we haven't started the mailer service yet, so let's start the mailer service. Before starting, I'll just give you a walkthrough of what exactly the definition of mailer service is. I'll just hide this for now. The terminal is not needed for now, so I'll just hide this. And over here if you can see, current topics, order created. Okay, mailer service, if I just open, we are same for now, creating the Kafka object with the client ID as mailer service, because self-explanatory, this is a mailer service instance, and currently we have only one broker, that is 1994 localhost 9094. That's it. Okay, now we are getting the consumer instance. If you can see the difference over here, in the consumer, when you're giving the instance, we should actually pass the consumer group. Remember, any consumer should be part of a consumer group, and it can be n number of consumers in the consumer group. There are some caveats I'll just cover based on the partitions and all, but overall a consumer should be part of a consumer group, so you need to pass a well-defined unique consumer group for a different business use case. Okay, so in this case I'm just giving it as mailer service group as a consumer group. So whatever the consumer we created this instance, it will be part of this mailer service consumer group. Simple. Okay, then later we are just having this connect definition. So inside this consumer.connect, consumer connected, and you're subscribing to these topics, and the current topics what we have, only order created. So as of now, mailer service has a subscriber, and currently it is subscribing to only one specific topic, that is order created. You can pass an array over here. I'll cover that in user service, but as an example. Okay, so this from beginning as a fallback option. If in that specific partition, let's say the next offset is 4, first offset is 0, right? Overall, what does it mean? Like if there is an invalidation in the offset for this specific consumer for a partition, it will try to fetch from the earliest message. Simple. Okay, not the latest message. Now this specific block will simply subscribe to these topics what we defined. Okay, now this block consumer.run is a handler basically for each message what exactly you want to do. So in this mailer service, let's say I'm just adding a log over here stating the topic, partition name and offset. What is the current offset for this? What is the offset for this message? Okay, assuming that we are sending assuming that once we receive the mailer service, maybe we are sending an email. That's it, simple. So process order notification, in here we have this console log. You can actually send this as use some libraries basically to send an actual email. That's it. Okay, and if there is any error, console.error, disconnect. Simple. Okay, overall the main crux is Kafka instance getting the consumer object with this group, and we are connecting from this as a consumer to the Kafka, and we are later, once the connection has been established, we are subscribing to these topics, and this is the from beginning true. This is the handler for each message. So in this handler, you can have the business logic to send an email, process, whatever stuff it is. Okay. And also similarly, we have the SIGINT. That's it. So start mailer service. I'm just trying to connect from there. The whole bootstrap starts. So if you see the definition of connect, in this connect definition, if you see the whole thing is there, like connecting the consumer and handler and all that stuff. That's it. If you observe here, this mailer service is acting as a simple Kafka related microservice. Again, not like a HTTP microservice, but simple Kafka consumer service. That's it. No REST API, nothing. Now, before starting the mailer service, let's look at the messages overall for the order created. So in the topics, if you see here, total number of messages order created is only 10. User updated is 0 because we set the flag as false. Let me just send one message for now. Now we have number of messages 1 in the user updated as well. Okay, messages, if you see, this is the payload, already user email timestamp, simple. Okay, now at this stage order created we have 11 messages, user updated we have one message, and inside order created first offset is 0. Just keep an eye on this. First offset is 0, next offset is 5 for this partition 0, 3 for partition id 1, and next offset is 3 for partition id 2. Okay, now let's start the mailer service, only one instance. I guess this font size is a bit smaller. I'm not sure if I increase how this will look in the video, but I think this is enough. Let's start the service. So let's go to Kafka practice folder, and over here we can just simply start npm run mailer service. That is how I define. There are some set of errors over here. If I can see, in the earlier state as the initialization, there can be there won't be any Kafka consumer group to act as a leader and all that stuff. So you can ignore now, and you can basically read these. The group coordinator is not available, but after an attempt, after some heartbeats, if you can see, currently this message is important. This specific line will just go to this line across all the terminals, so just keep an eye on it. So over here, if you see, is leader is true. So out of the consumer group, at any point of time, at least one consumer will act as a leader. Okay, so in this specific instance, in this terminal, right, we just created only one mailer service, and this is acting as a leader, and member assignment is nothing but, okay, for this topic order dot created topic, how many partitions this consumer is assigned to. Right now all three partitions are assigned because in this consumer group we have only one consumer instance, that is mailer service, only one instance, right? So all the partitions assigned to this specific instance, simple. Okay, and now if you see here, if you just go down, we just consumed all the messages from beginning, all the messages. If you see offset 1, offset 0, 1, 2, 3. Okay, now let's jump back to the diagram and let's update it with the current configuration. Okay, so over here the mailer service, currently the consumer, let me see if I can just add it as a consumer group. Okay, and we have only one mailer service consumer instance. Okay, one for now, and as of now all three partitions are assigned to mailer service one instance, one consumer over here. Okay, now let's just add the arrow notation so it's a bit easy to see. So all three partitions. Okay, see, all three partitions map to single instance mailer service. Looks a bit odd though, but if I can just change the color, maybe green. Yeah, so p0, p1, p2 all to single mailer service instance, only one consumer right now. Okay, now let's start the another consumer and see how the remapping gonna happen, and at least one partition will be assigned to one consumer and the other two partitions will be assigned to the one consumer. Now let's start another instance over here, npm run mailer service. It will take a while, just the next heartbeat I believe. So over here if you see, whenever I start one instance, we got one log message in the previous instance as well. So let's start with the latest instance. This is this active instance. Over here if you see, member assignment, is leader. So second instance what we spin it is, which is not a leader of course, so leader won't be keep switching, but the latest one, the first one which is already created in as a first consumer in the consumer group usually stays as a leader unless it gets shut down with whatever the reason it is. So the new instance second term, so this is first, this is second terminal, is leader is false, and member assignment if you see order dot created, if I can just expand maybe something like this. Okay, member assignment order dot created 0 and 1. So first like 0 and 1 partitions are assigned to the new instance which is created, and if you see over here in the log, the old instance now it is remapped and it is pointing to only one partition, that is second partition only, because total we have three partitions. So old instance instead of three overall partitions, it just switched to, yeah, if you see there are some errors over here because as we started the new consumer, rejoining and all that stuff has happened, and it basically triggered a reassignment of the partitions as well. So order dot created old instance pointed to partition to 0 and 1 partitions are assigned to the new instance. Okay, now if you look at the diagram for easy understanding, mailer service, another instance, right? And this is first instance, so maybe let's call it as mailer service dot one. Okay, mailer service dot two. I think this is blocking my video part of it, so I'll just move it over here. Sorry for the previous activity, but if you see here now, as per the logs over here, now if you see over here, as per the logs over here, latest instance order service 2, let's say consumer 2, right, has reassigned to 0, has been assigned with 0 and 1, right? So let's do that. So partition 0, this arrow will be pointed over here. Partition 1, okay, this arrow is pointed over here. So now in this consumer group, let's call it consumer group. Okay, okay, so this consumer group, now we have two consumers in this consumer group and three partitions. As we started mailer service 2, which is second consumer, now due to the reassignment, partition 0, earlier all three partitions mapped to mailer service 1 because at that time only one consumer is there. Now we have two, due to the reassignment, partition 0 and partition 1 assigned to mailer service 2, the new instance, and partition 2 assigned to mailer service 1. Okay, simple. Now let's send some more. Total we sent 3 with the same user 1. So most probably this will end up into one specific partition 0, and we received all three messages. If you see 1, 2, 3. Now let's change it. Earlier I think with 2 it switched to different partition. So user 2, let's say send. Okay, user 2 also came to the partition 1. So let's see if I can just do user 3, maybe send user 3. Now if you see user 3 came received by first consumer. Okay, what if user 6 send, user 6 came to second consumer because it ended up in partition 1, simple, user 6 over here. So right now we have two consumer instances in the same consumer group, and as we have three partitions, one partition assigned to the first older instance and 0 and 1 basically. So I mean third partition assigned to the older instance of mailer service, and the new consumer mailer service second instance is reassigned with partition 0 and 1. That's it. Okay, I hope till this part it is clear. Now let's run one more instance as well. So simple command npm run mailer service. Now if you see the the three terminals will get a logs accordingly. Now if you see all three services got an latest log message. If you see over here, leader is still the old instance, the very first instance what we created, and member assignment currently this first consumer is assigned to partition 1. Simple. So let's update the diagram as well for easy representation. Partition 1, this one, right? So this assigned to over here. Let's take another instance over here, mailer service 3, because now we spin the third mailer service as well, which is a consumer. So now in the second instance, of course, each leader will be false, and member assignment, it is assigned to this topic of course order created, and the partition is 0. Okay, now let's jump now in the diagram. Partition 0, it's still same, so there is no change over here. Okay, then look at the third instance. Now it is set to second partition, third partition, which is partition 2. Okay, so like this. So this is how the partitions reassigned. Okay, now let's verify again. So first instance, partition 1. First instance, this arrow, partition 1, maybe like this. Okay, first instance. Now second instance is mapped to partition 0. Okay, third instance mapped to partition 2. Simple. Now in the previous video, I emphasized one very important concept, like at any point of time, the number of consumers in the consumer group can be more than the number of partitions, because one partition, one single partition can be pointed to multiple consumers in the same consumer group. It can be pointed to different consumer groups that I'll just cover in the later video, but simple, at any point of time, one single partition can be pointed to multiple consumers in the same consumer group. That's it. Okay, now let's start another instance and see how this thing behaves. Okay, so mailer service 4, let's call it. Okay, now let's open the terminal, and maybe I'll just minify this. So 0, so 1, 2, 3, 3 mailer services, 3 consumers are already running. Now let's run another instance and look at the behavior. Okay, mailer service. Now let's wait for the heartbeat. I think it is done. Okay, all right, so it is done. So let's see, with the latest instance consumer 4, which it started, if you see, each leader is false, but tricky part, member assignment, so it assigned, so the new instance got assigned to partition 1. Let's update the diagram. Okay, I'll just cover that. Partition 1 is this one, so new instance got assigned to mailer service 4. Okay, now what exactly happened to mailer service 1 then? If you see, this is the first terminal is mailer service 1. If you see, this is leader, still it is leader, but member assignment is 0. So this specific message, this specific consumer will never receive any messages, but still it will act as a leader. Let's send some messages. Okay, user 6, if I send user 6 is being consumed by the latest mailer service instance, that is mailer service 4, which is consumer 4 overall. Okay, and if you see, self-explanatory, partition is 1, and as per the diagram, partition 1 is mapped to mailer service 4. Okay, now let's simulate some more, maybe user 1. Let's see how this thing goes. Send, and in the terminal, so user 1 with the latest timestamp, this is being picked by mailer service 2 instance, and partition is 0. Is it correct? Let's look at the diagram and confirm. Partition 0, mailer service 2. Simple. Okay, now you might be having an thought like, okay, what if we run another instance of mailer service? Let's try it out. npm run mailer service. So this is the 5th instance. Okay, now let's see, we wait for the whole heartbeat thing is done. So now if you see, the first instance, which is still leader, is true, so this consumer is still true, but member assignment is 0. So no message will be consumed, because there is no partition assigned to this specific instance. Now if you see here, the second mailer instance got assigned to partition 0. Is it still same? Let's verify. Partition 0, mailer service 2, correct. Now mailer service 3, third terminal, which is assigned to partition 1. Is it still correct? No, right? If you see, this is the third instance, right? Mailer service 3, and the partition assigned is 1. Currently, earlier it is assigned to 2. So let's do one thing. Let's update this. So partition 1 assigned to mailer service 3. Then what about the partition 2 then? Let's see. So this is fourth mailer service instance, right? And now if you look at the member assignment, so this is also got off. So fourth mailer service has no partition assignment. Let's create another one, mailer service 5. Alrighty, self-explanatory. Now the new consumer instance receives the gets assigned to partition 2. Let's verify that. So this is the fifth terminal, right? Now if I just look at the member assignment, right, order created, partition 2, simple. I hope till this part it is clear. So let's just add this one, partition 2 mailer service 5. That's it, right? So as long as the number of consumers keeps increasing, the first service instance which is still active, which is acting as a leader as well, but it is not assigned to any of the partitions. It will make sure that if any of the instances got off, the leader will decide if you need to reassign anything. I think this actually creates a nice business use case, right? So actually, so this specific situation will create a new use case. What if we just stop the mailer service 5, right? Let's see. So we'll just kill this mailer service 5 and see how the partition reassignment gonna happen again. Okay, so this is the fifth terminal, 1 2 3 4 5, fifth terminal. Let's kill. Okay, now let's wait for the next heartbeat and see how this thing will re-update. Okay, looks like it's taking some time, but let's wait for some more time. Let's see. So mailer service 5, I just shut it off. So let's remove this one. Let's see how the assignment gonna kick in. Okay, looks like it happened now, right? So this got killed. Now we got the latest info over here. Yeah, now it happened. Let's see. So still the first instance got no member assignment. Over here, the second instance is still 0. Is it correct? Yeah. Partition 0, second instance correct. Third instance, partition 2. If you see now, again, it got reassigned multiple times. Not just it just added to mailer service 4, partition 2, right? So yeah, partition 2 now reassigned to mailer service 3 instance. So earlier it was partition 1, but now it decided it will give it to mailer service 3. Then self-explanatory, partition 1 will be assigned to mailer service 4. Let's check. Order created, member assignment, partition 1. Simple. Okay. Till this point, I believe it is helpful for you guys. If you do so, please make sure you hit that like button and subscribe, which motivates me to do more interesting content like this. Alright, now the fun part. What if we just shut down the leader consumer instance, this one, mailer service 1. If you see here, as of now, member assignment is 0. This is correct. No partition assigned to mailer service 1. However, this consumer is acting as a leader, so which will basically all the reassignments what is happening, this consumer leader is deciding, right? What if we just delete this? Either of these three, the next three will become a leader. Let's see. Okay, let's shut it down, control C. Let's wait. I think the heartbeat is taking a while, but let's see. So this is mailer service 1, which is shut down. Mailer service 5, this is also done. So one of these three, 1 2 3, like 2 3 4 instance names, right? Let's see. Let's wait for a while. Okay, yeah, now we got. So if you see here, is leader is true. Okay, now let's look at the assignments as well. So this is mailer service 2, right? Partition is 0. Is it still same? Correct. Okay, is it the leader? No, is leader is false. Now look at the third mailer service instance, that is consumer 3. Is leader is true. So now this mailer service 3 has become leader, because earlier it is a leader. As we shut it down, mailer service 3 became a leader. So is leader and the assignment is 2. Is it still same? Correct. And then later mailer service 4 instance is leader false, of course, and order created is 1. Like this, sorry, the partition is 1. This is still same. That's it. Okay. I think this is self-explanatory at this stage as we are not touching anything. Maybe as there is no already assigned partition for this mailer service, but it is a leader. If we just delete it, there is no reassignment happened over here. Just that the leader assignment happened. One of these three has become leader. That's it. Okay. I hope till this part it's clear. Now let's cover user service and see how this thing goes. Just open user service over here. So if you look at the pattern in user service, it will be similar to the mailer service. In this case, if you see, the topics are both user updated and order created. So let me just see if I can use this chunk over here quickly. This will be consumer group of user service, right? And only one instance because we have only one partition. We'll try the same behavior. Not that useful anymore because we extensively tested the consumers on and off in this example. But let's see. So now we have user updated, right? I just want to zoom out. Might be a bit hard in the mobile views, but let's see. Okay, consumer group user service. This is user updated. This is one topic, and we have only one partition P0. Okay, let's look at the Kafka UI ones. Okay, just let's refresh topics. We have user updated partitions only one. Total messages 9. Okay, let's open this user updated message. It's clear, and first offset is 0, next offset is 9, total messages count is 9. Okay, only one partition is there. All right, then let's just user service one, only one instance for now. Okay, now jumping back to the code. So we have user updated, order created. Two topics this user service will subscribe. Simple. Okay, let's look at the user service definition. Same. Kafka instance. Now the client ID is user service, broker defined. Then group ID here is user service group. Okay, so this is the consumer group name, and we are connecting that to the Kafka. Same stuff. Topics. So these two topics, this specific user service consumer will subscribe to these two topics, user updated and also order created, and each message handling. Okay, assume there is some DB operation, some stats that you need to prefetch or pre-calculate and save it in DB, something like that. Okay, that's it, simple process. So I think this is a copy paste issue, you guys can ignore this one, but let me just remove. Okay, cool. There's no use of order data as well, but assuming that's okay, let's do one thing. Instead of process order notification, let me see if I can just process user update. Okay, also it's updated, updating user, something like this. Okay, items it's not required, but yeah, I hope this is clear. Same as mailer service, just that the topics are two now, and the consumer group is user service group. Mailer service group. Okay, consumer group, mailer service group. Okay, and this consumer group is user service group. Okay, simple. Let me see if I can just zoom in. Okay, cool. Now let's start. Okay, right now this and this are both off, so I'll just try to minimize these for now. Let's use this terminal. Okay, npm run, that would be user service. Simple. Okay, now let's see. So consumer subscribe to topics, and it tried to basically read all the consume all the messages from the order created, because this specific consumer group never read any messages from the order created topic, right? So that's the reason it just showed over here. Let's see if he received any other user updated also. See, topic user updated. As we consume, as we can subscribe to two topics, order created and user updated, and it starts with offset 0 from here as well. Okay, okay, so now let's look at the Kafka UI part. Let's refresh. We have another tab, consumers. Okay, if you see here, the defined consumer groups, how it got defined. Okay, user service group, mailer service group, total number of members 3, assign partitions 3. There is no consumer lag, there is no such heavy load as of now. User service group, only one member, because we have only one consumer defined. But if you see here, the number of topics which are subscribed are both you order created and user updated. Simple. Okay, now let's send one more message and just verify. Okay, overall. So over here, because this ended up in partition 0, this message has been consumed over here. And also order created, user 1, the latest message, maybe let's see if we just do 100, just for an easy identification. Send. This thing came over here again into the same partition 0, user 100 and user 100. Okay, both order created and user updated, both messages consumed, right, from the user service. Let's update the diagram. Will be lot of arrows, but I'll just change the color code for now. Let's make it blue. Okay, P1 and also this one, P0. Okay, now this also, because let me see if I oopsie. Orange over here, this also, right? Okay, P0 clear. So at this stage 3 services are running, mailer service 2 3 4. This is like an index based, so 1, right? So this is off, 2 3 4, fifth is also off. Now we have user service 1, which is there. So as soon as the user service is up, all the partitions for this consumer group has picked up and these are assigned. And now user updated, only one partition is there, so as this specific partition just assigned to first instance of user service 1. Now let's the other fun part. Now the other fun part, what if we just start another user service instance? Any guesses? Let's see. Okay, let's wait for the heartbeat, and once it's joined, consumer has joined the group. Okay, now if you see, there is one slight change over here. It's not just that only once all these things will be assigned. So let's see, let's copy paste this one, user service to over here. Okay, now if you see here, if you look at the latest log, consumer has joined the group ID user service group. And if you see here, is leader is still true for the first user service instance, and user dot updated, only one partition is there, so there is no change over here. But user order dot created, only second partition got assigned. I hope if I can show you the older one over here. Yeah, I think I haven't covered when it started, but yeah, is leader true for the very first time when I just started over here, right? npm run user service. So for the first instance, is leader is true, of course, because it's only one consumer in this consumer group. Member assignment, user updated 0, order created, order created 0 1 and 2, all partitions. Now as I created another user service in the user service group, it's best, obviously the order created topic has 3 partitions, it will be reassigned, right? But it won't be having any effect on the user updater, or maybe it got removed from here and just assigned to over here only, because we have only one partition. So at any point of time, one partition will be pointed to one consumer in the same consumer group. Okay, all right. So in the second instance, if you see order dot created, for this topic 0 and 1 partitions got assigned. Now let's just simply update the diagram as well. So 0 and 1, 0, this arrow, and 1. So this is the thing happened. Now if you start another one, it just another so one partition will be removed from one user service 2 and it just adds to the user service 3. That's it. Now let's run it, send, and now let's look at the thingy. So here, as it ended up in partition 0, you can confirm over here the same message. Let me see if I just add it. user 101. Okay, now let's send C and see which service, which partition it got picked up. User 101. So now the partition is 1. Okay, so the same message will be of course consumed by or mailer service and user service. And this case, as the message ended up in partition 1, it is received in the user service 2, consumer 2 basically. Okay, now see if we can um, send any message to partition 0, sorry, order created 2, right? Yeah, order created 2 to user 1. I'm not sure how that thing goes, but let's see, maybe we'll just use or user 2 and send if this ends up in partition 2 by any chance. Nope. Okay, but let me try maybe. Anyway, at the end I have this autocannon where we'll just simulate a heavy random data across, so it will just goes oh yeah, user 25. Now see, partition 0, and this came over 25 over here. That's it, I believe. Is it what I'm trying to look at it? Oh, we need in partition 2. Sorry, my bad. Let's see if we can just send 251 send partition 2. Will it? Oh yeah, lucky enough. 251 user 251. Yeah, partition 2. Now if you see the 251 partition, uh, order created. Yeah, partition 2 user 251. Simple. Okay. I hope till this part it is clear, right? I will just create another, maybe I'll just use this terminal to create another instance of user service. Basically, as right now we have only two, so we'll just do it over here, and one of the partition gets assigned. Let's see, or maybe the this thing like the reassignment of p0 might also can happen. So user updated 0. Oh wow, if you see here, now the new assignment has switched to the latest thingy, right? User updated 0. So this arrow will go all the way to user service 3. Okay, now what about the order created partition 1? So order created partition 1, this arrow is going to user service 3, consumer 3. Rest all I believe it stays. Order created 0. This is for the first one I believe. So p0. Oh wait, so this first one order created 0. This also got reshuffled now. So this came over here, and this one p2 will be for user service 2 I believe. Order created p2. Yeah, that's it. So the whole reshuffling happened over in this case. Okay, so this is the current state of our services. Makes sense, right? Let me just kill this one. That's fine. I guess the latest one. Let's see. I just stopped the user service 3 now again. Let's see how the rebalancing gonna happen, and I'll just okay, the heartbeat is taking a while for the next scan. Let's see if we can get it quickly. Okay, new message up, new log came, user updated 0. Now this thing again came back all the way to user service 1. This is not there, so let's remove this aside. User service 2, let's see. Order created only 2. So the first, for the first instance, oh wow, now the thing came to, so partition 2 of order created came to user service 1, order created 2, and 0 and 1 will be for second instance. So 0 and 1 both. So this 0 and 1 pointed to you. So lot of reshuffling happening. Okay, that's pretty much it. Okay, I believe this is all helpful on the practical side of it. Now I'll just show you one another script that is autocannon, that is like a benchmarking tool. I just written a very dummy thing just to see how the data will just try to randomly flush it via this API and how this thing goes. And also, so this is the same connection. So number of connections overall is 3, and for each connection how many requests, duration is 5 seconds for now, and this is the payload data. And for in the setup client function handler, so in the setup client hook basically you can override the client body or any other headers as well. So we're just overwriting the body over here by randomizing some data, price, quantity, and also user email. I'm just using the same nano id over here to generate. I'm basically randomly generating the primary block of the email address. That's it. Okay, and these are just the aggregated results and all that stuff. That's it, nothing fancy. So this is a good tool for benchmarking. So let's just run this one as well. I'll see maybe if we can use the VS Code terminal now, because it almost ran off. I think there are some free, but let's use VS Code for this one. I'll just split this over here like this on the right side. Now let's run npm run AC, I believe. Package JSON AC or run autocannon. Yeah. So let's run this npm run AC. Okay. Now if you see all the messages, the logs are being flushed over here because we are just sending almost 7,000 requests. Now let's look at the thingy. We can't see now because it's all flushed up. But if you see the user email, it's all random over here, and all. Maybe I'll just do 10 seconds and I'll just show you this one. Apart from this, let's look at the Kafka UI. If you see, the number of messages will be exploded. See, order created. So this IN is basically in internal topic. You can ignore that one. But order created total, we have 7358 messages. And in the inside user updated, we have 7348. If you just go inside, the offsets also gets updated next off, because all the messages already consumed. Simple. Okay. Let's do one simple fun activity at the end. So duration, let's make it 10 seconds. Okay. Fingers crossed. Let's see npm run AC, and I'll just open this one. So if you see, all the messages being consumed across all the partitions, and user service are also getting all the messages. Yeah, that's it. Now let's look at the Kafka UI again. Let's refresh. And total messages at this stage 24,000. Sorry, 25,000 in the order created. See, we can also do one small activity at the end. That is, now let's remove the user update flag. So let's send this as false. Earlier when we did that activity, all the user services also being consumed with the user updated also. But now if we do, we'll just consume only order created topics, right? Now let's trigger that autocannon again. Okay, fingers crossed. I'll just go through it. But if you see here, order created, it's just going on this part only. We can simply look at the Kafka UI as well, order created, and it's picking only order created for the user service. How the big difference, if you see here, there's a big chunk order created. Let's see. So it got stopped earlier. Right now, if you look at the number of requests, it total requests came around 22,000 change, right? And earlier it is 25 plus 22 roughly, right? That's how the numbers are different over here. Order created, now the user updater didn't receive any message, so that's the difference of around 22,000 change. Simple. Okay, that's about it on the practical side. I tried to give a better explanation how the consumers gets reassigned when there is a change in the number of consumers per consumer group, and how the different consumers keep switching the partitions and all that stuff. Okay, and we just did with autocannon as well, so it will give you the big picture how the consumer cell gets spread across all the partitions. If you see here, for the last iteration 22,000, right? If you see inside for partition, almost it got evenly spread out. Maybe because earlier partition 0 has more trials and that's how it got affected, but that's it. I hope this video is helpful as a continuation to my previous video, which is Kafka fundamentals. Earlier video, I got some better views, around 1k plus in a less duration. I'm very happy for that, and also some people have already commented stating that they want to have a practical video, and this is a practical video. Hope this helps. Thank you so much for watching, and make sure you hit that like button and subscribe, which will again motivate me to do more interesting stuff. That's it. Thank you so much for watching again, and I'll see you in the next one. Bye.